Okay, we're going to go over the proof of cosine law. Here we have a triangle and a familiar form of cosine law. And a lot of these times these letters are interchangeable. Usually they call this angle C. We're going to call it theta for this, but it's essentially solving the angle opposite of this side C here. Okay, so with cosine law we usually have these sides of the triangle and we're solving the angle, or we have two sides of a triangle and the angle between them and solving for that opposite side. We're going to use Pythagorean Theorem and primary trig ratios to help prove this law. So in order to do this, we're going to draw an altitude. We don't know how long side A, B, or C are, but we know the altitude, which would be the height of this triangle, is perpendicular to this base, or side B, which means this is a 90-degree angle. Okay, and we're going to call this the height, H. Okay. On top of that, what we're going to do is this B here, we're going to call this side X of our right angle triangle. So from here to our 90-degree angle is X, which then means that from here to our other point, which sometimes could be called angle A, is going to be B subtract side X. Okay, that's going to be the distance of that side there, and that's going to help us along in our proof here. So in our first proof, we're going to kind of separate our two right angle triangles. This will be triangle 1, and this will be triangle 2. And when I talk about triangles, I mean our two right angle triangles. So this is number 2, and this is number 1. So triangle number 1, we're going to set up Pythagorean Theorem actually with it. So we know that a squared will be equal to h squared plus x squared. Okay. And with that being said, in triangle 2, we're going to do the exact same thing. We have our c squared is going to be set equal to h squared minus our side here. And normally it would be just a letter, but in this one we're going to have to actually write it as b minus side x squared. So these are two proofs of, or two uses of, sorry, I should say, Pythagorean Theorem. And in both of them we have h. So we're going to set them both equal to h and then do some substitution here. So that being said, in our first formula, or first triangle here, h squared can be set equal to a squared minus x squared. Okay, and essentially all we've done here is I moved x to the other side, it became negative, and I just flipped the two sides of the equation and put h squared on this side and the a squared minus the x squared on the right here. Okay, and with the same one here, I'll do very similar. H squared can be set equal to c squared. Sorry, this Pythagorean was wrong. That should have been plus, right? Because the formula is c squared is equal to a squared plus b squared. So when it comes to the other side, it becomes subtracted by b minus x squared. Perfect. Now since we have both of these set equal to h squared, what we can do here is I can substitute this value in for this h squared, or vice versa, this value in for this h squared. And to visualize this better, maybe if I move the h and the equal sign over here, you can see how these two essentially are equal to each other. And so because they're equal to each other, we can kind of combine these two formulas. They are now set equal. So let's write that out. That'll give us our a squared minus x squared is equal to c squared minus our b minus x squared, and b should be green here. Great. So now that we have that, and remember our cosine law here, we're setting everything equal to c squared. So I'm going to move our c squared to the left side of the equation and everything else to the right. So when, or actually, let's vice versa that. Let's move all of this to the other side. So c squared is on the right side of the equation by itself. So c squared is equal to the a squared stays minus x squared. And then when this bracket has this negative in front of it on the right, when we move it to the left side of the equation, it will become plus b minus x squared. And we're going to switch everything around just because In our cosine law, we happen to have c squared on the left. So c squared is equal to, and we'll rewrite it over here, a squared. And this is really, we've made no progress in this step here. I'm just rearranging things so it's a little more familiar looking to us, plus. And actually what we'll do in this step is we'll expand that. We'll expand this using FOIL. So if you were to use FOIL, you'd end up with plus b squared. Because this is negative x, you'd have negative x times b and negative x times v together become minus 2b times x. Okay, and then finally a negative x squared, or sorry, negative x times negative x is positive x squared. And this should be squared here. So we're going to collect our like terms. So in the first set here of like terms, if you notice we have a negative x squared and a positive x squared. Well, those two essentially cancel out. They create a 0 when we put them together. So this now reads c squared is equal to a squared plus b squared minus 2bx. Now x is the only thing that's a little different from our cosine law. But we can figure out what x is equal to. Let's use our cos value of theta. So for instance, in this right angle triangle, our triangle number 1, what we're going to do is we're going to set cos theta. Cos theta equals adjacent, which is our x, over a. Sorry, I couldn't see that for a sec. Divided by our value of a. Okay, well we want to get x by itself, so we'd move a to the other side of the equation, and it ends up being that a times cos theta is equal to x, which is perfect for us now, because now we know we can use this to replace our x down here. So using that information, maybe I'll drag it down with us here. Drag this all the way down. There you go. We're going to replace the x in this equation. So now we'll read c squared is equal to a squared, and we use the same colors we've always been using, plus b squared minus 2b. We're going to replace our x value with our a times cos theta. So 2b times a times cos theta. And in our other formula above, the only thing we did was rearrange the a and b, but due to associative property of multiplication, it doesn't matter what order they're in. So you notice we've now created a proof. C squared equals a squared plus b squared minus 2ab cos c. C squared is equal to a squared plus b squared minus 2ba, same thing, cos theta, or cos c.